I will explain Newton-Raphson method for finding solution of equation of the form fx is equal to 0. I'll explain this method with the help of this graph. You consider this one. Let this be the graph y equal to fx, and we have to find out solution of the equation fx is equal to 0. That is, finding x in such a way that y equal to 0. So in this case, this is the root of the equation. We have to find out this point. So in Newton-Raphson method, we will start with an initial approximation that is denoted by x naught. So we will choose a value x naught that lies near to the root, and then we mark this point. So this is the point x naught, f of x naught. And from here, at this point, we will draw a tangent to this curve. And this tangent passes through this point. Let this be x1. So we will take this x1 as the next approximation. And now we mark this point, that is x1, f of x1. So at this point, we will draw again tangent. And then the point at which the tangent meets x-axis will be taken as the next approximation. Let it be x2. So then, like this, after a finite step, we will reach the real root. So then, this Newton-Raphson method is also known as method of tangents, because we are finding the actual root by drawing the tangents. Now we will derive a formula for this one. So then consider this one, this tangent. So this tangent passes through the point x naught, f of x naught, and equation of that one is y minus f of x naught, f dash x naught, x minus x naught. And now this line passes through this point. That point is x1 0. So y is 0, x is x1. So I can substitute here, that is 0 minus f of x naught, that is equal to f dash x naught into x1 minus x naught. So this is the first approximation. So then simplifying, you can see that x1 will be equal to x naught minus f of x naught divided by f dash x naught. And then similarly, we can find out the expression for x2 by drawing the tangent at x1 f of x1. And we can see that this is x2 is equal to x1 minus f of x naught by f dash x naught. So we can generalize this formula. So by generalizing, the formula is x n plus 1 is equal to xn minus f of xn divided by f dash xn, where n is equal to 0, 1, 2, etc. So then I'll explain this one by using one example. Suppose you have to find out positive root of the equation e raised to x minus 4x is equal to 0. Suppose you have to find out a positive root of this equation. So I'll take f of x as e raised to x minus 4x. Now in this case, we have to find out initial approximation first, that is x naught. So then what we can do is, this is only one method. There may be different methods actually. So then what we can do is, you can find out f0. So then f0, you will get this as 1. And then you find out f1. So in this case, we can see that f1 is minus 1.28. You see, f0 and f of 1, they are of opposite signs. One is positive, the other one is negative. So we can say that there is a root between 0 and 1. Suppose this is also positive, then you go for f of 2. Okay, suppose f0, f1 both are positive, then find out f2. If f1, f2 are of opposite signs, then the root lies between 1 and 2. And like that it goes. So in this case, the root lies between 0 and 1. So you can take the initial approximation as either 0 or 1, or you can take average also. So you can, in this case, I am taking x naught as average of 0 and 1. This is x naught is 0.5. So this is the initial approximation. Now you can find out the first approximation, that is x1. This is the formula. x1 is x naught minus f of x naught by f dash x naught. So you have to evaluate f dash x also. So this is fx, and f dash x is equal to e raised to x minus 4. So then x naught minus, that is 0.5 minus f of 0.5 by f dash 0.5. So then we can see that this is equal to 0.3506. And now x2. x2 will be equal to x1 minus f of x1 by f dash x1. So this is equal to 0.3573, and x3 is equal to x2 minus f of x2 by f dash x2, that is equal to 0.3574. Now you see these two are equal up to 3 places of decimals. Now you go for one more step, then you can see this is equal to 0.3574. You got the same value in both iterations. So therefore, we can say that 0.3574 is a root of this equation. Actually, this Newton-Raphson method is a simple method, and its speed of convergence is good. So in finite number of steps, you will get the final answer. But this fails when the denominator is 0. Suppose if you are getting f dash xn at any of these steps, suppose f dash x naught is 0, or f dash x1 is 0, or f dash x2 is equal to 0, at any of these points, if the derivative is 0, then this method fails. And you know the geometrical meaning of the derivative, that is slope of the tangent at the point, at a point. So then the slope is 0 means the tangent is parallel to x-axis. In such cases, it fails. So then we can use some other numerical methods. In the next video, I will be explaining another numerical method, that is called iteration method, for solving fx is equal to 0.